to show you how you can analyze data from a food effects study and generate outputs, tables, and figures that you might need for that analysis using Aplos NCA. So the first thing we'll do is we will upload a data file, and we have some food effect data. You can see it's stacked. This is like what you might get from a bioanalytical laboratory. And we have not done our BOQ handling. We need to do some data processing. We'll go ahead and show you how to do that at the end, but I believe this is 12 subjects and a two-way crossover, so there's 24 profiles in here. So we're going to go ahead and import that data into Aplos NCA, and we'll upload it to the account, and then when the upload is complete, we'll do the configuration. Now for this configuration, I'm going to leverage some JSON files that I pre-prepared. So I click on config JSON. This is the analysis configuration, so how the NCA is performed. And I'll go up here and I'll upload a pre-prepared JSON file that I have. And I'll go to our data cleaning and I'll select that, my data processing JSON. And then lastly, I'll have my post-processing JSON, which does the relative bioavailability calculation, the tables, and the plots, as well as the report. So once I've uploaded all of those, I go ahead and I can click execute, and this will send all of those up to the server and with instructions to analyze the data set. Now you'll see that it says it's processing. This analysis time down below is the time required for the data cleaning as well as the calculation of the PK parameters. And then the full runtime includes any post-processing that's done. So in this case, post-processing included the custom calculation of the relative bioavailability, tables, plots, and a report. So we'll go ahead and download those results. And once those results are downloaded, it's a zip file. We can go ahead and open up that zip file and we can show it here. And in the inputs, you can see we get the input data set as well as these configuration JSONs that were uploaded. And then in outputs, we get all of the results. And I'm going to open up the report just to show you what it can produce. And I'm going to make this a little bit bigger so you can see it. So here we have an appendix, might be for a report, and here's the first table, which is the treatment of 0.1 milligrams of the drug fasted. Then you have all 12 subjects, and you have selected parameters that I've included in there, and then I've included the summary statistics for those. And then I have the same thing for the fed state. And then the third table includes the relative bioavailability parameter calculations. So we have the relative bioavailability based on Cmax, on AUC all, and AUC 0 to infinity. So they're all calculated there, and then you have your summary statistics. The geometric mean is likely what you would see in a least squares mean analysis rather than the arithmetic mean, but you can see that they're all relatively close. It's about a 20, this is a 27%, and this goes up to a 29%. So 27, 28, 29% increase in bioavailability in the fed state. And then we have some custom plots. So here is all of the subjects on after the fasted treatment on linear, and those same subjects on semi-log. And then we have the fed treatment on linear and on semi-log. And then we have combined. So here is the combined fed and fasted, with fasted in the red or salmon color and fed in the teal or green color. And here it is on semi-log. So you can see the slightly larger exposure in fed. And then we have it with error bars. So here are the error bars on linear, and here's the error bars on log. So you can see very quick to produce all of the output that you might need for a fed and fasted study. So let me go back and show you actually how we can do the data cleaning. So if we click on our data cleaning tab here, we can select that file that we were using, and we have several activities that we need to do. So for example, we needed to add time units and concentration units and dose units to the file. We also wanted to convert the dose to milligrams. It was in micrograms. And we want to add those new dose units. Then we had some BLQ handling that we wanted to do. And then finally, we wanted to add a study day as well. So we can go ahead and start adding those things. So if we click this little button here, we can actually see the file data. So you can kind of scroll up and down. You can expand this if you want, and you can zoom it back. But we can see, okay, we need to make some changes. So we're going to first add the units. So let's add those 3 units. So we're going to go add 3 columns. So we just click on add column 3 times. And then we close this and we come to the first one. And so we can, add units for dose, and we're going to call it dose units, and it was micrograms is what it was. And then we're going to add concentration units, and this was nanograms per mil. And your column names, they don't have to be these. You can't have spaces in them. So that's why I'm using the underscore. But there we go. We've added those. And I also said we wanted to change the units and convert from micrograms to milligrams. So for that, we're going to do an arithmetic conversion. And then we're actually going to add a new column that has those new units. So let's go ahead and do this. So this is going to convert the dose from micrograms to milligrams. And so my source column is going to be that original dose column. And my destination column, we'll call it dose 2. Actually, take that, we'll call it dose underscore milligrams. And then our operator is, we're going to divide, and we're going to divide by 1,000. And we don't need this. If you're using another column to do your division, you could enter that column here instead of a value. So we got that done. Now let's add the milligram dose units. And so we're going to call it dose milligram units, and of course it's going to be milligram. Okay, so we've added all those. There's something else we want to add, a study day text. So if we open up the file and look at it again, we can see study day is just a 1 or a 7. And maybe in our plots, we want to have it say day 1 or day 7. So we'll go ahead and do that now. So we're going to add a column, and then we're going to do a find and replace. And I'll describe how these are used. So the first thing is we're going to add study day text column. And so we're going to call this one day underscore text. And I'm just going to put day 1 in there. So the value is going to be day 1 for all subjects. So it's just going to fill that column with day 1. Now we know that's not right, because on day 7 it should be something else. And so we're going to do a find and replace. So we're going to replace day text with day 7. So my source column is going to be that study day column. And I'm going to look for a value of 7. And when I find a value of 7 in the day text column, I want to replace it with day 7. So it's an easy way to, it's almost like a conditional, but it's a little easier if there's only 1 or 2 cases that you have to deal with. And then the last thing we need to do is handle BLQs. So there's 2 types of BLQs. One is we want to set everything to 0. And we use that for our plots and our concentration tables when we want to summarize. And then I choose to do a BLQ before and after the first measurable observation. And so I'm going to do that. So I'll add those 2 in, and then we go fill those out. So we're going to set all BLQ to 0 for tables and plots. So our grouping columns, we want to group by subject, but then we also want to group by period because there's 2 periods for each subject. Then we say grab the time, and then the existing concentration column was CONC. And so we're going to call this one PK level, and it's going to find, oh, I don't know what BLQ text. So let me look here. I can open up the file and look. Okay, it's BLQ. That's how we've defined, the lab has defined BLQs. So I'm going to look for BLQ, and I'm going to impute a value of 0. So that's it. It's all set for that. Now we do the same thing. So this is before and after the first observation. I'm going to do the same thing. I'm going to group by subject and period. And then I'm going to take time and my existing concentration column. I'm going to call this PK level 2 so that it's different. And before the first observation, it's going to be 0. And after the first observation, it's just blank. And then in the BLQ text defined, again, it's BLQ. So that's all I have to do. And so now I can go ahead and I can clean the data. And so I'll just click this button up here and I can clean the data. So what it's going to do is it's going to run through each of these rules and it's going to clean the data. So it says rules were processed successfully. So there's a couple things here. First of all, you can actually view the full, here's the full JSON that did all that analysis. So you can download that to your computer and now you have it for an analysis. That's how I got the JSON to upload previously. Another thing that we can do is we'll go look at the results of the cleaned data. So I'm just going to open up a new tab here and I'm going to wait for it to load, and then I'm going to switch over to the input data page. And sometimes it looks like nothing's here. You just click refresh. It just hasn't loaded the files yet. And you can see here's a food effect data cleaned. And if you switch back, that's what the name of the file is going to be, cleaned. So we go look at that and we can actually, again, view that data file and see, remember it stopped at this day here. And now you can see there's dose units, concentration units, time units. There's our dose in milligrams, and then it's got a day text, a PK level, BLQ flags, and then another PK level. So you can see that it's done all the conversions that are needed in order to correctly calculate all the parameters, and it's cleaned the data and it's ready to go. We're building similar tools to this data cleaning for the post-processing rules, and then you'll be able to build tables and plots and reports and things the same way that you built these rules for data cleaning. But that's how you would analyze data from a food effects study with Aplos NCA.